Hey, hello everybody. Thank you for coming. As Marcia said, I'm Mae Culumber. I'm the nut crop advisor in Fresno County. And I recognize a lot of you, getting to know you and enjoying it over the last 2 years. I've been here since June of 2016. So today I was going to focus on talking about the nutrient management plans and then maybe a little bit about what we're looking at in terms of what kind of irrigation season we might have with all the precip we've been having this late winter. So I guess just starting off with the irrigation. So heavy rain, I think a lot of us have gotten accustomed to getting that first fertigation on as early, even as late March around now. But with as wet as everything is, it may be good to just try to hold off. ETs, the evapotranspiration, of course, is very low, and as soon as things dry out, we get some patterns with sun after these rain patterns go away. We'll probably be jumping into it pretty quick, but just depending on your soil, depending on the type of soil that you have, if you have heavier ground, you're going to have a lot of moisture in the bank, and so it's good to if you use ET as a means to schedule irrigation, you can actually on my website and then in other counties, we have a lot of information about how to calculate what the evapotranspirative loss has been for this growing season compared to what you have in the soil to help you best time when you should be turning the water on, when it's needed. Not just what we do out of habit every year, but trying to make that a little bit more of a science. And I don't have an official sign-in sheet, but if anybody's interested in being on a weekly email list where we have ET reports that we'll send out, so it's based on a mature bearing, full bearing tree, about 7-year-old tree, and we reference several of the different CMIS weather stations throughout Fresno County and some of the other adjacent counties. So, and not just for almonds, but almonds, pistachios, walnuts, citrus, and stone fruit. So if you have any interest in getting a weekly email to help you kind of fine tune your irrigation plans, let me know.
So maybe we could make a note on the sign-in sheet. We'll send it around again, and you can make a note if you want to get her publication. How's that?
Okay. Thank you. That's great. Okay, and then so as far as the nutrient management plans, so being that it's the end of March, was it March 1st that those were due to be turned in March 1st? Okay, and so I'm sure as you were filling those out, it was kind of hard to predict what yields were going to be like, especially it's like bloom looked great, but then we had all this really unexpected cold, and we're not entirely sure yet how badly that's going to impact the yields. So when determining these nutrient management plans, there's a lot of, it's like you get the initial prediction of what you're going to use, and then we're going to need to modify it as the season goes on, and a lot of that's going to depend on what your predicted yield is. Maybe historically you have to average about 3,000 pounds per acre. Maybe you're looking at about 2,000 pounds this year. So we need to be able to account for that in our plan. And then leaf tissue analyses. The UCD and the Almond Board recommends doing the April sampling to model the predicted amount of nitrogen that's going to be available in July. So they recommend using that as another tool to modify your plan as you go. So the current recommendation is that you put on your fertilization in 20%, 30, 30, and 20 through the growing season. When the trees, we're through the dormant season, when trees are not actively taking up nitrogen, but our best understanding is, once we get to this leaf out stage and through fruit development, that's when the trees are, actively taking up nitrogen, and so that's sort of the sweet spot of when we want to apply. By the time we get to hull split, the amount of nitrogen that's being taken up by the trees really drops very, very rapidly. So we want to get those applications on between now and hull split. I'm sure a lot of you guys have had experience with this already, but maybe it's a good review. So one, how do we calculate our fertility needs? So let's say we're thinking about a 2,000 pound crop per acre. So our best estimate is that that for every 1,000 pounds of nuts, we take out about 68 pounds of nitrogen with the crop load. So 2,000 pound crop, we're looking at about 136 pounds of required nitrogen. But we're getting nitrogen from other sources than just the fertilizers. And that is a lot of the reason why the regulations are having us account for that. So your irrigation water can be a large source of nitrogen. And then also the soil carries over some residual nitrogen. And then sometimes you may be putting in some other organic amendments like composted manures or manures to try to raise the organic matter of your soil and increase the retention of nutrients. And so we need to account for all of these things. And so yesterday we had a farm day up in Chowchilla, and I talked about just how you go about doing soil and water sampling. So I could go over that a bit right now. But what you want to do is get a picture of how much nitrogen that we have in the soil at the beginning of the season, and account for that and give yourself credit for that on your worksheet. And so, usually most people, when they do an annual soil sampling, we recommend that you do that sampling about this time or maybe a little bit earlier. You want to be as close to when you're going to start fertilizing or when trees are going to start taking up the nutrients as possible, so that we think that it's representative of the amount of nitrogen in the soil. And we're interested in the depths of the soil where that corresponds to your rooting zone. So a younger tree is going to have a smaller rooting zone than, say, a fully mature bearing tree. So a lot of people may do that type of sampling with just your standard spade and bucket. But if you're a grower and this is a really good investment, it would be one of these soil probes. So it's not only good for doing this once annual sampling, but it's also a nice tool to see, check your soil moisture and things like that. I mean, soil moisture sensors are great. They provide us with a lot of information, but that's a really small area of influence in your orchard. It's just telling you about, the spots where you have those sensors. So it's also a good tool to walk around and see how well your irrigation sets are reaching down through the root zone. So anyway, so what we want to do is get an average of, let's say we're interested in the 4-foot rooting zone of our orchard, and we need to think about where it's going to make the most sense to sample. So if you're really lucky to have nice uniform soils with, with not a lot of spatial variability, then you may just be able to sample in 4 to 6 places across the whole block and send those in. But usually everybody has some variability across the block. So you want to start with what do you already know about your field? Where are the bad spots? Where do things drain more slowly than others? Where does water go right in? And that's probably evidence of either textural differences or maybe even some chemical differences with salinity in the soil. So you can keep that in mind. You can go on the web. You could go to your local NRCS office and ask them to help you out get this soil survey maps for your area. Another good resource is if you go on the University of California website and type in soil web surveys. There's several different web applications that you can use where you just type in your address and it'll bring up a map and it'll show you lines that show you the different soil designations. So you can kind of use that as a guide to where to sample. And so let's say we've got a field with 2 zones, and in those 2 zones we're going to want to take at least 4 to 6 representative samples. And so I marked on here 1 foot increments where I would take a sample. So I would take out my probe, I would take the first 1 foot increment, and I would like to have, depending on the depth we decide to go to, let's say we're doing 4 feet, you'll want to have 4 5-gallon pails, marked 1 through 4, Okay, and so you auger out that first foot of soil, put it into number 1, you go back into the hole, auger out the second foot, number 2, 3, and 4, and then go at random to another place in that same zone. Okay, and we're going to composite the samples. So you take when you get to your next spot, you're going to take that 1 foot increment and just mix it in with the 1 foot amount from the other hole. And you're going to do that 4 to 6 times, and then go to the second zone, do the same thing. So this is a lot of sampling, but we think that once a year that it's worthwhile to know where you're at. One thing that I didn't mention going into this is that it's not just a good idea to look at your nitrogen management because because there's more requirements now. Being on target with your nitrogen management can really help. It could increase your yields. It'll help with the growth of your trees and probably extend the longevity of your trees. We don't want to be pumping on more nitrogen than what's necessary. When that happens, the trees they get under stress, especially the young trees. They can get burned. So we want to be, using as precise methods as we can. So one way to do that is to understand how much residual nitrogen is in the soil. Okay, so you're going to put those composited samples that you just took, and you're going to drop them into some Ziploc bags. Lacey is here with Del Valley, and she confirmed to me that about a quart-sized bag of soil is sufficient to bring over to the lab. So you want to mix up what's in those buckets really well, and then just take out a representative sample. Make sure the bags are labeled really well. They say location, your name, the date you collected it, and what crop you have. Okay, and then have them do a total elemental analysis of the soil so you can get a good snapshot of where you're at for the year. Okay, so with those reports when they come in, actually first I'll talk about water again before we move on to that. We also want to account for the amount of nitrate that we have in our water source. So if we're pumping groundwater, we want to get the system going for about 30 minutes. It removes all the static water that's in the system that may be in a different state than the water that we're going to be putting onto the field. So you let the pump run for about 30 minutes. You want to take a clean container that has a nice tight screw top lid and rinse it out a few times with the water, and then fill it up all the way. Try to have no air pockets in there. Minimize the amount of air in the jar, seal it up tight, and then get it over to the lab as quick as you can. If you can't get to it that day, just make sure you refrigerate it and get it over there. Okay. So now, as far as the nitrogen goes, different labs may report things differently. When you're selecting a lab, you can look online. I would tell you that it would be good to ask them if they do the national, tell me this acronym is right, the NAPT certifications, the National Analytical Proficiency Testing. Okay, that means that all those labs every year, they have to go through QC analysis and make sure that they're getting accurate numbers that are standardized by the National Proficiency Testing Agency. So that's important, and it's a good question to ask because not everybody may be getting those accreditations. So you ask about that. Okay, so the labs will report back to you, since we're talking about nitrogen right now. It can be in two forms. They might tell you the amount you have in nitrate, which would be NO3 minus, or it could be N-NO3 minus. So that's nitrate nitrogen. Now the difference between those two values is that nitrate represents the whole compound. Okay, so that's all of the nitrogen in there plus the oxygen. Okay, the nitrogen in nitrate makes up only 22% of the molecule. So when you see nitrate nitrogen on there, that reflects that 22%. So you know that when it says nitrate nitrogen, that reflects the nitrogen, not just, not the nitrogen plus the oxygen. And that's the number that we're interested in. If you need any help making that conversion or anything, sorry I didn't prepare handouts for you today, but I have my card. You can give me a call and we can talk about that. Basically, so you're going to get these values for your irrigation water and for the soil. And it's fairly simple to, let's say you have the number in nitrate nitrogen, and for the nitrate nitrogen, you would multiply that number in parts per million by 2.72, and that'll tell you how many pounds of nitrogen that you're going to get per acre foot of water. So if you're going to apply 3 to 4 acre feet, then you would multiply that number times that amount, and that's what's going to give you that credit that you would put on that worksheet. Okay, the same thing with the soil. Instead of accounting for the acre feet of water, we can just think about the volume of soil in the ground. So there's about 4 million pounds of soil for every acre foot of soil. So if we have 4 parts per million of nitrate nitrogen in the ground, we'll multiply that number times 4 for the 4 million pounds in an acre foot. But if we're not just interested in that top layer, we're interested in the volume down to 4 feet. So you multiply that number times 4. So 4 times 4 times 4. So we got 16 times 4. Somebody help me. 64. Okay, so that would be a 64 pounds credit that you would apply in the root zone. Okay, but we're not done yet. Those aren't the numbers that you'll put down, because most people now have not, I mean, a lot of people use a combination of drip and flood, but for the purposes of doing this calculation, say everybody in here is on a drip system, that would only account for 60% of the webbing area that the tree is, extracting the nitrogen from. So we're going to say that, okay, we have those credits, we've added those credits from the water, from the soil, and now we're only going to account for 60% of that, because that's what's available to the tree. Okay, so these are, did you want to add something, Lacey?
Oh, I was just going to say, if those conversions worry you at all, we actually now do have a lab output that does if you take a 4-foot sample or a 3-foot sample or a 5-foot sample, on the nitrogen, it will actually calculate how many pounds per acre foot, and it will automatically have that into a separate column, and then we can actually now set it up where its efficiency is right there, so then it's just a plug and chug from your lab. Yeah. Right.
Yeah, and I mean, it's like you can do these worksheets by hand if you want, but they're, like the different labs have web applications available now. The Almond board has the CASP tools. So there's a lot of tools on the web that you can use that can help you with these calculations. Okay, so you'll say, okay, you can, so if we think that with a 2,000 pound crop that we're estimating we're going to have, we'll subtract that 100, so we think that's about 136 pounds of nitrogen per acre requirement, and then we can subtract that, whatever 60% of 64 pounds is. So anyway, we'll subtract that on credit, and that's going to tell us how much our nitrogen requirement is from the inorganic fertilizers that we're going to apply. And so there's another efficiency coefficient, is that we think that only 70% of that, we get 70% efficiency from that nitrogen application, so we need to account for that too. Okay, so you'll end up with a final number of what you need to apply for the year, and now we're going to break it down over the 20% in your first fertigation, 30% in the next 2 doses, and then 20% at the end around whole split. Okay, but nothing ever goes as planned, right? So we get a good idea as the season goes on of maybe we're getting a little less crop than we thought, maybe it's looking a little better than we thought, and then we do leaf tissue analyses to tell us where we're at. And so some of the recommendations right now are to do an April sampling of your leaf tissue analyses, and then a lot of the labs will model forward for you and tell you where you're going to be at in July in terms of adequacy or deficiency. So when you get those results back, you can modify your plan either up and down more. Where things get tricky is that you've already put on, by the time you get some of those results, you've already put on half of what you calculated. So you can't go back, and you don't want to just, stop fertilizing the trees. So you would make a new say that we estimated that we were going to need a little bit less than what we did. You would still follow that 20-30-30-20 rule. So you would adjust your number down a little bit and still apply 30% of that number, 20% of that number. If it gets to July and you're finding that your leaf tissues, you're actually a little bit high on nitrogen, when you do that if you do that test before you put on your last dose of N and your yields are down from what you originally predicted, maybe you may want to forego that last fertilization, okay? Because we know that the trees are not actively taking up the nitrogen or start to decrease. So, but yeah, those are just decisions that you'll need to make on an annual basis. I think what else? Are there any questions?
In all of the things we tank mix, some of them have an N value, and it's small. But is it necessary to consider that on a management plan? When they want a total, and I'm putting in some spreader activator that's got some N in it for something I'm doing, but it's really minute, but it's in.
Right. Yeah, I would say that they probably do want you to do. I mean, I guess that's up to your jurisdiction. But I would say any foliars, any
well, beyond, I mean, foliars have a predictable value.
Right. But when the nitrogen's a lesser component, and you're
I'm putting something in with Roundup, mulberry weed, but there's some N in it. Is that important?
Yeah. I guess you could do some back of the envelope calculations, and if it comes out to be about like 2-3 pounds.
So it's important to understand when you describe the calculations, that's helpful for me.
Okay.
Because there's a lot of sources for N, they're not all coming out of the lab.
Right. And a lot of it's just our best guess. I mean, especially something I kind of glossed over, compost. We can get a nutrient analysis to tell us this is how much nitrate and ammonium that you're getting from that. But that's, just, one little sample from, a couple ton application. And so that could vary quite a bit across that. And then how much of that is available. A lot of the nitrogen that's in that, in the manure and the compost is organic nitrogen, and it's not readily available. We know that some of it's going to become available through the season, but we're like, is that 15%? Is it 25%? We don't know. So I mean, it's we're in that margin of error. We're just doing do the best we can. Right. But if it's a small amount, I don't know if you need to worry about it.
Hi, when's the best time to take the soil sample?
So with regard to the nutrient management plan, that would be early in the year, so it's spring, before your first fertigation. And if these are due March 1st, maybe you would want to do it in February. I think the labs usually can get it turned around pretty quick. But yeah, you want it to be as close as you can to when you're going to start fertigating. If you have other concerns with salinity issues and things like that, then you may want to do sampling in the fall, to figure out how you can approach reclamating or reclamating the soil during the dormant season. So.
You mentioned an evapotranspiration website early on.
Oh, yeah.
Do you have the URL for that? Is it available publicly on?
Yeah, if you go to the Fresno nut crops page, I post the weekly ET reports on there, and then I have a email list where I'll send it out. It's just a PDF, and it lists the different commodities and then several of the different weather stations, so you can figure out which weather station you're closest to, and it'll tell you how much precip we've had to date, what the estimated ET is for the week for your crop, and so that might be helpful to help guide you with coming up with your irrigation set for the week.
Yeah, I've been trying a couple of different Google searches and it hasn't been coming up.
Oh, okay.
Yeah.
What kind is that?
It's I'm doing it. The Fresno County one covers Tulare, Fresno, and Madera. Kern County, I believe Sandon has it. I think David and Roger are covered up in Stanislaus and Merced. So we've got pretty good coverage across the valley.
And it's always available in cities.
And it's always available on CIMIS, but you would need to do some of the calculations on your own. These we apply the crop coefficients for you for the different crops. So. Okay, if there's no more questions, I guess. Do you have anything you wanted to add about anything? Okay. Irrigation.
What about form of nitrogen, early versus later?
Right. Yeah. So yeah, different fertilizers are gonna, if you use urea-based or ammonia-based fertilizers, they will have a longer residual time in the soil than say some nitrate-based fertilizers. But all of them become the same by about 2 weeks or so. So yeah, just the urea and the ammonium have to go through different transformative processes, and when they're in that stage, they're more stable in the soil. But once everything goes to nitrate, it's very mobile in the soil, especially if you have lighter textured sandy soils. A big rain or a big irrigation set will essentially probably be pushing anything the tree doesn't take up down below the root zone, and it's going to be lost.
I'll add something to that. I would stick with early fertilization. I'm not a big fan of this whole you got to use CAN 17 or calcium nitrate because the soils are too cold for conversion. Your soils are always above 55 in California. You measure them, they're warm enough. This idea that you don't get conversion of urea through March is complete bogus. And so you can stick with any form of nitrogen you want to use. It's just that you run a greater risk of nitrate leaching when you're using a nitrate-based fertilizer, especially for spring rains.
But don't you need to have the roots active at the time when you apply nitrogen?
The roots are going to be increasing in their growth as the soils begin to warm. But for the most part, you're not getting uptake until you have leaves on the tree. So
I'm thinking of pistachios that haven't been out yet, so my grower will have to wait until they start getting down, right?
yeah, pretty much. They're not going to. There's some small amount of probably active pumping, but not enough to warrant a large application on the ground.
Heavier ground hold the nitrates longer than sandier ground?
Some of the heavier ground that we have is probably generally higher pH, and so, which means, I'd say the soil colloids are more negatively charged when you have a higher pH, and the nitrate molecule is negatively charged, and so there's kind of an inversion there. But yeah, I would say that it probably does hold it longer, but I don't know. What's that?
Holds more water.
Holds more water. So yeah, your water's not moving as quickly through the profile, so the nitrate in the water would be staying longer, but how much longer than a sandy soil? I don't know.
A plant only absorbs so much, right?
Yeah, and so that's
it
the
will
idea.
overdrain.
Yeah, and it's just, if we had higher organic matter levels in our soil, there's more potential for some retention. They're holding on to the nutrients, but in general, our soils are pretty low in organic matter in the valley here, and so, there's just not the potential to hold on to nutrient reserves. So the thinking is that whatever isn't taken up is likely going to be lost through leaching or, depending on the type of fertilizer, devolatilized. So.
I have a question on the coalitions on the nitrogen. Some of us have been reporting for the last 3 years now. Has it shown any trends as far as over nitrogen, under?
I don't know, David.
We're not, we don't get access to that data, so I couldn't tell you. Yeah, I don't even know.
I'm just was curious.
I would think that just with the amount of, just with the amount of people going to drip irrigation systems, I mean, that's got to help with the reduction, because we're keeping water more at the root zone, and it's not as easily being lost below the root zone. And so if the water's not moving, below the root zone during the growing season, then maybe we're not losing that much.
There was a claim that it was getting worse during the drought, that groundwater nitrate levels are actually increasing, but that most likely is due to the reduction of volume of water that's in the groundwater as we had declining groundwater reservoirs. So I think it's too early to tell, and I think it's a 50-year problem. That's a legacy issue we're dealing with. It's something that's been going on for 100 years, and now we're trying to manage it and think we're going to solve it in 5 or 10. It's going to take 20 to 30 to 40.
Yeah,
probably.
because there's no way to determine where that nitrogen came from.
There's good indication it came from over-fertilization, but
City of Fresno.
yeah, but a lot of this is guilty, but I remember reading research reports in the almond boards where they're putting on 1,000 pounds of nitrogen into the dormant.
Yeah.
So, well, it was in the research proceedings, from the 1960s and 70s. So, we learn as we go, right? Isn't that the process of research? I mean, if you look at where we went from 1,000 in dormant to now we're putting with 2,000 pounds and we're putting 250 out with 3,500 pounds.
Well, clearly the research should have been caught up, but it wasn't, so no, I agree with you.
Yeah.
Okay. Thanks, Mae. So I'm going to